And it's 6:30, so we'll get started here. We'll talk about synthetic slings here in a minute. The code of conduct item of the week is to work the OSHA, and all our safety standards, and of course all the others that we have to comply with. Corporate announcements, we have one new employee, Alfred Bruce Karavu. Is that correct? Is he here? Alfred? No. Well, hopefully I pronounced his last name correctly. Apologize if I didn't. Congratulations to Megan. Megan was married last weekend to Jack Badger. Sits up at J Peak. Very nice. I don't know Jack. Anyone know Jack? He better be a good husband, we all say. Okay, technical tips. Back again, still with fluid mechanics and pumps. Move this over here. So, we've been talking about pressure. And there's a lot of different ways to look at pressure. And this week, we're talking about kind of a hydrostatic pressure. So a good example is the dam, but for the pressure increases with depth, of course. And the weight of water is 62 pounds per cubic foot, as we show there. And so if you have 10 feet of water, it's just 62.4 times 10 feet, 624 pounds a square foot, or 4.3 psi. And kind of the cool example here is a dam, right? And dams are obviously set up for resisting the hydrostatic head pressure applied to the upstream face of the dam. I'm missing an H here. Ray, I did make a mistake. We weren't quite done. We should have had a little H here.
Well, I was surprised I didn't get any markups on you.
Yeah, I didn't look at it carefully enough until last night. So there's a height of water, and that pressure is the weight of water, gamma times H. And it actually is a force. I didn't show it as a force, but it's a pressure here. There's a force applied to the dam, and it's resisted by a little friction of force on the dam, under the dam, and the weight to resist that horizontal force. And also, when you look at a dam, you look at the overturning, too, the potential for the dam to flop over based on that load going this way. There's a weight this way, and it's all balanced about that tipping point at the toe. Of course, that's kind of idealizes an impervious base, and the reality is there's a lot more complicated forces on a dam. And for one thing, there's really considered an uplift force underneath, because if you got water at the tail and at the reservoir here, there's obviously a change that's happening underneath there. So it can actually even make it worse by uplifting it. So if we try to make a little cofferdam out in the field, it isn't just that horizontal force pushing against the cofferdam. It's an uplift force that can destabilize, roll it over, or slide it. And even this, is simplified. Here, sometimes they look at a crack underneath, which would mean that full hydrostatic pressure goes over before it starts tapering. And then there's other conditions like, let's see, we might have flooding, so water might be going over and causing a lot of dynamic forces against the dam. Ice loading, siltation against the dam, there's seismic loads, and a variety of combination of loads of different safety factors reflect the probability. And sometimes you add different conditions. Maybe a seismic event happens with a high pool rather than a low pool. So really one of the points here is that your hydrostatic pressure increases linearly with depth. So you go down 5 feet, it's half as much. You go down to 10 feet, it's at 624 pounds a square foot. Water, as everyone knows, is a very powerful force. Usually a force working against us, right? Instead of for us. So this week we're looking at a project, the Sand Plains #1 horizontal directional drill, the 2,335 foot long gas transmission line crossing a tributary of the Indian Brook. And this pipe was pulled in early Wednesday, 5:45 a.m. Had to get pulled in one stretch, continuously.
Is that one of my rails?
I doubt it. No, not at all.
It looks similar to me.
Yeah. There's pumps hanging off that. So the big slurry pit here that's pumped to the reclaimer, and also the P&P guys there leaning on his hose, sucking it out. So the pipe came in. This is early on in the pull from the Severance roadside. 4 strings of pipe had to get attached, 3 welds, coating, x-raying, everything to disrupt our pullback. Otherwise, we would have been about half the time, or probably a lot less than half the time. Maybe a third of the time was actually pulling. There's the Ogre, the 26-inch Ogre reamer, back reamer. Came out of the hole. Pretty gnarly looking set of teeth and everything. And we added additional reverse teeth. There's actually teeth right here facing the opposite direction of these for reversing, pulling backwards, whatever. And let's see, we weren't without problems. Right, Larry? Larry's, Pat, is this familiar? Sunday morning, brand new equipment, and the clutch fails. So Larry and Pat responded, and within 4 hours, we had it up and running. They had it up and running again. So pretty impressive on a Sunday morning, and clutch goes, and we're back and running in less than 4 hours. That was not from the time they were there. They were there a lot less than 4 hours. That was from the time we couldn't get going.
Where'd you buy a clutch on a Sunday?
Took it off somebody's truck.
Okay.
Yeah, we went up to Charlo Boys and dropped it. Yeah, Charlo Boys in Burlington responded very, very nicely. And pretty common clutch on a Road Ranger transmission and a Cat engine. So that's what I got, and we're going to talk about synthetic slings here.
Thanks, Ken.
Yep.
So last week we had a little discussion just on chain slings and the importance of chain slings and doing your inspections. Today I'd like just to talk about, or this week is going through our trails, going through what we have of synthetics and looking through it and making sure we have up to speed synthetic slings out there. We have all different types, shapes, and sizes. So it's important that, again, before you pick and use these, you guys are going through them and looking for defects such as this one. I'll pass this around and you'll be able to see what a damaged synthetic looks like. This one's kind of been faded so bad that actually you can't even see the markings. There's actually red nylon inside. When you see that red, you need to take it out of service. Also, we should also be able to see the working load limit of all our synthetics, and I'll go basket, vertical, and choker hitch. If you cannot see these identifications, you need to take that out of service. These are very handy tools for our toolbox for rigging. What's great about synthetics is they're very light. All right, very lightweight, easy to carry. But again, with sunlight, with oil and grease, it takes down the synthetic wear, and they would fail like that one that we have there. So we want to make sure we always know what the manufacturer trademark is, the capacity, and the type of material. Again, just looking at your synthetic slings, the wider the sling, the more working load capacity it has. The narrower the sling, the less working load capacity it has. But you should always be able to identify it by looking at your synthetics. So again, do not use around acids. Remove from service if acid or caustic burns, melting or charring of any part of the sling surface, snags, punctures, tears, cuts, broken stitches, or distorting fitting. Sometimes when you're using it around a shackle, you might really get a lot of wear in the mouth of the synthetic because your shackle isn't big enough and you're crumbling the front part to hold it in a shackle. So you sometimes might want a wider shackle with a wider synthetic. So it's very important. We use a lot of these, especially in our crane work. Also, with just basic rigging and hitching. Again, we mostly use chains, but there is a lot of synthetics out here. It needs to be put away, not in the back of pickup trucks. It should be hung from job trailers. So make sure everybody goes through your trailers this week, look for damage and defects, bring them into service. Originally, if you can't get them back, please get a tag system from the tool crib Just write do not use and tag it out of service so no one uses it, okay, on site. This should definitely be something taken out immediately, because when those fail, they fail very quickly and suddenly, and you don't know when it's going to happen. So again, when in doubt, take it out of service. Is there any questions when it comes to synthetics? Since we're going to get into more rigging and hoisting after next week's wire rope inspections that we'll talk about next week. There's no questions. Let's have a safe day out there.
It's pretty
Plan our work.
impressive how much you can pick with these things.
Yeah.
We have some twin path. That's good for what? 100,000?
Yeah, there's
You can
all
pick it up
up to
with your finger.
500,000. And
Pick it up with your fingers.
So light, yeah, lightweight.
Yeah. But you got to keep them out of the mud and keep them clean and fresh.
Yeah, exactly.
Kind of surprising the Jeep.
Eric Merriman.
Stephen Michael. Come on in. Come on, you.
Right here, Scott.
Hey, Bobby Moreau.
You're ready to go.